holding me. Oh, I am free. Oh, I am free. I'm free and oh free. No more chains holding me. I'm free. I'm free. Oh, 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 yeah.
Huzzah! Welcome back. I think in the last video we were waiting for our pH and EC probes to arrive. Guess what came in? I think in the last video too we were talking about working with a smaller set of EC probes that were sort of a brick style and pH probes, and we were going to put those in the corner of our application, and that turned out to be a problem with those ones because they didn't have what's called power isolation. And what that means is that when you have both an EC and pH probe in the same water source running at the same time on those older ones, they would cancel each other out because the current off of them wasn't isolated. But there was a guy on the last video that commented on my problem named Cam Dinkirks, who pointed me out to a company called Atlas Scientific that has gotten around this problem, and they build basically everything we needed for our application. So let's start from the top. In the middle here we have what's called the tentacle shield, and this is a shield that stacks on top of the Arduino and allows you to stack other things right on top of it, such as our LCD. And this shield breaks out slots, and it happens to be exactly for our application, that have little circuits. And they design these little circuits to be specific for different applications. So we have 2 EC circuits and 2 pH circuits. And we'll get more into that when we get into the box itself. But just know for now, we have a new shield instead of little boxes. And we've summed everything up into little tiny microchip circuits. Okay, we do have 2 pH probes, and this is what a pH probe looks like. When you're not utilizing it, they give you a little solution to store it in because you don't want to ever just store these dry. I went ahead and got Atlas Scientific probes because these can be fully submerged, like all the way, wire, everything. So they're a little bit more spendy, and they're rated to last 2 years if you use the right solutions like reconditioning kit and storage solutions. And then with the 2 probes, I got my calibration solutions, which is a pH 4, 7, and 10. They recommend a 3-point calibration. You can get away with a 2-point calibration, but I went ahead and got 3. Moving over, we have 2 EC or conductivity probes, and that's what they look like right here. And these as well are a little bit more spendy because they can be fully submerged, wire and all. These also are a little bit more spendy because they're rated to last 10 years, which is, wow, just amazing. And then your calibration solutions. And then this is your cleaning solution for cleaning the probes. So before I went ahead and put my money into this company, I had a lot of questions because this application was very niche. And going to their website, they seem really on top of their game as far as all the documentation, everything. And so when I reached out to them, I was expecting to get sort of a sales rep that was more or less just pushing me towards buying. But no, it turned out this is a really small team of people in New York, and the person that I talked to, I sent actually a couple emails. So the first person I talked to was actually the person who put my order together. I mean, from manufacturing the circuits, to testing, to putting in the box and making sure it went out the door. So, I mean, that's amazing. These guys are just awesome. All right, so before we move on to actually hooking this up, let's talk about some of the changes that I've made. Okay, so coming on to the right-hand side of the actual cabinet, and just marked a little X and drilled some holes here. And I'm going to I took a dime and I laid it on top and just outlined it. I'm going to take my Dremel, I'm going to finish that off. And that will basically allow us to fit the whole housing unit, or I'm sorry, the whole sort of plug unit into there, and it will hang down the side. Alright, so let's get that done, and then we'll plug in the sensors to Arduino. Before I forget, I should also mention this update that I had to make too.
All receptacles that you get, including these two that we have the individual outlets linked together with a little tab that you can actually break off. You're allowed to break that off. That is a requirement for our build because we want each outlet to be its own outlet, and so we don't want feeding power to one to also give power to the other, and then we want them to be individual channels. So on this side and the other side of this particular receptacle, you need to break off the tabs, and the same thing for the receptacle on the back too. You need to break off those two tabs, and that will basically unlink those to be individual channels like we want.
Alright, quickly moving on. Let's talk about the wiring configuration changes I've made in the back. First of all, the biggest change is going to be the power source. So before we had a power transformer that was taking AC and giving a dual output of 1 amp 5 volts and 1 amp 12 volts. This almost worked perfect for our application. We couldn't use the 5 volt 1 amp side to run our LEDs off of because of ripple and just not enough amperage off of this transformer. The LEDs were very, very dim. If you tried to run everything off the 12 volt side, when it came time to use our full flushing and our irrigation valves, you would get our LCD up front would start flickering and get pretty dim as well. I just didn't trust it, so I stepped up to a 12 volt single output 3 amps, and we're still running power off of that into our relay here, and we're running that into the relay daisy chained. The first, 8, 9, 10, 11, 12, the first 12 relays. And then we're taking a power line and ground to a new breadboard that we have back here. Okay, and that goes into the back rail there, just for room's sakes. And you'll see that primarily the ground side of that is now being utilized by the pump motors. And before I told you to daisy chain your grounds of your pump motors, and that turned out to be a bad idea because it builds up EMF, and when you shut off the motor, that buildup goes back out to the Arduino and it resets the Arduino, which isn't good because we kind of want that to not happen. So star pattern, or running those two dedicated grounds, fix that, and that's why we have a breadboard back here. You can see I glued those in place with a hot glue gun just for peace of mind. And then if you look closely on the terminals, the pump motors, I have diodes, and I'll go ahead and list any new part that we talk about in this video in the description below. And this diode goes across the terminals in the correct direction, which is positive to positive and negative to negative, and that prevents that buildup that may occur even in a star pattern from reaching out to the Arduino. Kills it. You also notice that I have completely ignored the pattern. They told me to hook up positive to the positive side with this little positive symbol here, and ground should go down here, but I flipped that around. It's because if you don't do that and run it as they diagrammed here, the motors go from right to left. That means if you're looking at the front of the motor, the water would be coming in from the right and going out the left. Now our application is set up to go the other way, which is left to right. It's the difference between sort of reading from left to right and right to left. So you just flip the power on those. You put ground to positive and positive to ground on the motor, and it will run backwards. Okay, so we cannot give the Arduino 12 volt 3 amp. It will not work. So we have to step it down. And we use a regulator, which looks like this, to do that. And this regulator is called L7812CB. So with this 12 volt 1 amp regulator, we're going to again be stepping down the 12 volt 3 amp power transformer here, and the load is going to be utilizing much lower than what can be output over here and what's going to be stepped down ultimately. So we're going to have some heat dissipation that we're going to need to take care of on this. And usually that's done with heat sinks. In fact, if you look at the power transformer here, I think they got some MOSFETs or maybe even some regulators to step it down from AC to DC, and they got some beefy heat sinks on there. I couldn't find heat sinks like that, but we are going to need to use heat sinks to dissipate that heat. The heat sinks I did find were these little guys,
and they work in respects to that they fit around this really nicely, but they completely fail for my application as far as what I need to dissipate, or the amount of heat that I need to dissipate. Even stacking some of these up and using thermal goop just wasn't enough. If you run without a heatsink, by the way, you're going to get anywhere up to about 160 before power going to the Arduino just starts fluctuating and your relays start snapping on and off like a snake, rattlesnake. So what I had to do was find probably the internet's most redonkulous size heatsink for much larger MOSFETs, or maybe even this application. And this, mind you, is huge. It's overkill. It keeps my temperature now at, I think, 90 Fahrenheit or 85 Fahrenheit. So I mean, it's you can touch it. It feels like room temperature sometimes. I don't know what you keep your room temperature at, but we're gonna take this, and the front of these regulators being where the print is. So this would be the front, this would be the back. We know that the power transformer's voltage or positive needs to come in on the left-hand side, middle is ground, and right-hand side is going to be our stepped down voltage. That's 12 volt 1 amp. Okay, so now let's talk about the remaining wiring on the breadboard here. So I'm taking a power line and a ground line off of this rail that's again being supplied from our power transformer, and I'm bringing it over onto the far side of the breadboard over here, and I'm running another power line off of this side of the breadboard out to the front, and a ground line out to the front, and that's going to go to our Arduino. So what we've done here is we've given us space to plug in this big beefy regulator and heatsink. And the way that works, I don't know if I can get in there close, so we're going to get those pins lined up, but we're not going to put it as close to the incoming power as we can, because we want to leave that rail open. We're going to put it right in between, and probably one more space, so somewhere right in there. And the reason we're going to do that is because right in here on this first available 3 slots, we're going to put some capacitors. Now these capacitors are, I believe they're rated at, there we go, it's a 1 UF 50 volt, so pretty small, just a single one. And if you look on them, they usually come with the legs, one of the legs being longer, so that way you know that's the positive side. I had to trim those down so they fit in the breadboard better, but you can tell which side is negative because it's clearly marked as negative. This side is positive. It's a little tiny positive sign down there, but it's there. So the way that works is that you want to put one capacitor in there so that the negative is going into the ground, and then the other capacitor is going to share that same ground pin. It's going to look like that. Let's see if I can get that focused. Probably not. There. So the negative sides on those capacitors share the same negative ground line, and then the positives are spread out to the outgoing power and the incoming power. And then lastly, we're just going to plug this guy right in there. And there she goes. And I think you could, if you wanted, probably trim those down. No, it's pretty close to the wide part of those legs. What I do recommend ultimately is gluing that, hot gluing that in, because the orientation of this is upside down compared to when it's going to be sitting on the wall. So this is going to be hanging upside down, so you really want to glue those in so that it doesn't slip out when it's hanging, but just by itself it's pretty hard to pull out, so I'm not too worried about that. Okay, so before dedicating that to be plugged in always, let's talk about some other things. Okay, so we have our irrigation valves now being grounded into the back breadboard here on the ground, and that just made a lot more sense because the holes to the irrigation valves are on the back side of the project box anyways.
And then also off of this back rail, which yes, it gets a lot of attention, I admit, we're running power to the actual relay system that controls the logic to the whole relay system. And then we're also taking a single ground from the bucket heads here, and we're bringing that into a available ground on this too. Before we had that ground going out to the front, but it just made more sense to bring it back here because it's already in the back of the entire project box. Okay, so with that, I think that covers everything. We can finally dedicate this fully and close up the back. Talk about some of the front changes. Alright, so quickly talk about the obvious change here is we have a new circuit board that is sitting in between the Arduino on the bottom and the LCD shield on top. And I went ahead and removed, I believe, 1 or 2 of the boards that I had stacked here. And that was all I had to do. And with that, we still reached that perfect height. So no worries there. The next biggest change is I went ahead and got a USB cable extender, but this is a special USB cable extender so that I have enough room or surface area to go ahead and hot glue that to this hole right there. So the actual port that we're plugging in the Arduino cord is right up to the side of the box. And then it comes down and around into a unique L shape that plugs in there because I do not have enough space to fit this, as you can see. Maybe if the hole had lined up before I had added that additional circuit, sure. But it still is kind of awkward with this additional space right there to try to wiggle it around and find the right spot and get it in. So now there's no problem. It's just in and it's out. Perfect. Let's come up to the SD card here. The SD card now takes its power and ground directly off of the LCD shield. And you can see the 5 volt and ground right there. That's because if you have it any earlier within the power circuit, when you go ahead and start running some of these big guys, like a 600 watt light, you're going to start getting some amp ripple, even though we have these capacitors, and you can try increasing those. I have an entire set somewhere around here, but it's not going to work unless you bring this up to the lower end of where this load is being used, and not somewhere up higher. Okay, let's look at the circuits on this tentacle shield. It sits between the Arduino and the LCD shield. It breaks out 4 additional circuits, which you can plug in Atlas circuits. We have 2 EC, which are green, and 2 pH, which are red. And we have those lined up in a way that we've broken it down the middle, so we have 2 sets. So this first set monitors our plant water, and the second set monitors our reservoir water. And the reason we've gone in that order is because if you're thinking about it, the first and most important water you should always be monitoring is your plant. So the first set is always monitoring your plant water. It's kind of a silly logic thing, but it works. We have some quick BNC cable extenders. Quick by, you can just unscrew these or screw these in and just run some grounds and voltage down here on the bottom. See that? I hot glued that in, and we run that to the other set of quick BNC connectors. You can see the hole right here is running the other set on the other side of the back side of this breadboard, and we did that over there. And coming over here, what I've done is using the grommets from our first video, that set, went ahead and just put those in place, hot glued it in, and came out looking nice and professional. And this is just so that we can easily connect our probes and not have it be completely committed to the box, and the box can be portable. I went ahead and labeled this clearly, so set 1 and set 2, and then EC and pH accordingly. Okay, coming in here, I think where I left off in talking about the back, we had just a ground and a power line coming in through the board to the front. And this is where it still goes into the original breadboard here. And then all the way down here is where we have the other ground and live line coming out here, powering Arduino with a quick power jack.
Okay, and I went ahead and broke off a ground and a positive down to here, and using the same level capacitors, went ahead and did that same setup that we did on the back, because we're going to be using this guy. And this is an L7805CV resistor, and I'm going to use that smaller set of heat sinks with this guy. And all we're going to do is bend these down a little bit. They're very forgiving. You'll see a lot of boards doing different funky things to them. And we're just going to plug this right in there into those three. So let's do that real quick. All right, now on the preceding side, it's kind of hard to see down there, I've broken out a positive and ground that come down to the lower half of the breadboard, and this is where I have some additional space to power some things. And right now I'm only powering, or I've dedicated this whole breakout to just the LEDs, which makes sense. So I wouldn't recommend putting anything else in there, and just dedicate this to the LEDs. I was just out of sort of space on this half of the breadboard to kind of plug those in and be confident that they'll stay there. So I broke it down to the lower half. So dedicated 5 volts to the entire LED strip, and that should cover all of the changes for the front. And with all the wiring updates covered, we can finally hang the DRO-Matic. And I've gone ahead and filled the bottles with water just to show you that the actual arms can support that weight, as well as act like a shelf on top. Just be careful when you have water or solutions on top that it doesn't drip. That was the whole purpose of having the nutrients and pH solutions below the electrical equipment. Okay, starting over here, we have the power to the DRO-Matic. Just going into a surge protected power strip. Make sure it is surge protected. I mean, the unit is surge protected. Do not plug the DRO-Matic directly into a wall. The power transformer is not surge protected, and you may have a failure, and you don't want that in the middle of a crop. Right here, I'm actually utilizing 2 of those power receptacles. The first one is going to my 600 watt light that I have inside of my grow tent. And the other one is going to the exhaust that I have going into the grow tent. You can see I have the ballast and the exhaust fan control right there. And both of those again can be timed from the operating system and interface. So all of my lights and exhaust can be timed from the DRO-Matic now. The first set of wires right here, these are going to the flow meters, data lines and power. And then back there again, we have our irrigation valves, power. Remember, those are clearly labeled right there to tell you which one is in and out for both irrigation and flow meters. So let's talk about flow meters. If you've watched my other video that I put out between making my last video and this one, I showed you how to automate a reservoir so that it will automatically fill up and stop where you desire, but it won't, and then when it drains, it won't start filling up until all the water is completely empty. And I mean completely empty, none of this leaving 2 to 3 inches of water in there. That whole system is separate, but automated, but it is separate from the DRO-Matic unit itself, except for the flow sensor, the inflow sensor. And you'll notice that is after the valve, which basically controls the logic for filling up. And the reason is because you don't want to apply all of the pressure that may be coming from a hose line or anything like that onto the flow meter. You want that onto the valve, and then you want the meter to be monitoring anything that comes after that. So that's the in meter for measuring flow. This would be the out meter for measuring flow, and that's the line that comes out of the reservoir into our plants. So in and out for flow meters, and then here's our irrigation valves. That one being in and that one being out. So again, from the reservoir into our plants, and then from the plant water out to drain. So in and out. And then coming over here, we have our probes that monitor our EC and pH coming out the side of the box and just coming down. And set 1 is monitoring our plant water, because number 1 most important water to be monitoring is our plant water. And then the second most important water to be monitoring is our reservoir for the dosing.
So, respectively, EC or pH, connect those. And I went ahead and just drilled some holes onto the lid of this reservoir. And these are just dropped into the side. And I already have a hole available for that. And then I went ahead and dedicated the actual nutrient lines into the lid of this reservoir. Again, if you've seen my other video about automating your reservoir, I've talked about this. Coming down here, we have our pH and up and pH down dedicated to the control bucket to our plants. And I should probably talk about that. So there's 3 different bottles for pH, and the way that works is that your reservoir is only dedicated to 1 bottle, because water coming in, whether it's reverse osmosis or directly off the tap, you know which direction that pH should be going. So you really only need to dedicate 1 bottle to that direction. But plants, on the other hand, as they're feeding and plant pooping, that drift can go up or down. There's a whole variety of factors as why it could be up and down, bacteria reasons. So we dedicate 2 whole bottles to monitoring up or down, so you don't have to worry about your plant drift at all. And maybe in a later model, I'm thinking about using some tiny little solenoid valves just for the size of the peristaltic pumps. And I could possibly just dedicate 2 pumps and 2 bottles to monitoring the pH of both reservoir and plant, and we would be able to free up 1 bottle for some amendments in nutrients. Alright guys, let's quickly go over how we're going to set up the operating system for the new DRO-Matic unit. So to begin, go to github.com/drolson/dro-matic. And once you're there, make sure you're on the master branch, and then go to clone or download. You're going to want to download a zip to your local hard drive, and go ahead and extract that to wherever you see fit. Once you're done extracting, go into the folder called Docs, and then into the other folder called Tentacle Setup. And in here you're going to have a tentacle setup.ini file that you're going to want to open up with the Arduino IDE. So I'll do that now. From here, you're going to want to go up to the upload button and upload that to the Arduino or the DRO-Matic unit now. Once it's done uploading, go to Tools and Serial Monitor. The serial monitor acts like a command window that you can send commands to the Arduino while it's running this code. So let's talk about the tentacle shield. The tentacle shield is set up with 4 channels to have 4 different circuits. And the way the DRO-Matic operating system is built is you're not really supposed to play with any of the pins, the jumpers that come on there, but the tentacle shield comes with 2 different modes. And we use one of 2 modes. Now the mode that we do use is the mode that is not default, that comes shipped. So this is why we need to run the tentacle setup and this command window, and we're going to change the 4 channels from what's called UART over to I2C. Now I2C runs a lot faster, and that's going to get us the speed off the probes that we need. So the commands that you're going to want to do are fairly simple. First of all, while that code is running and in this window, first hit 0 to enter the first channel. While you're in that first channel, you're going to want to type in I2C, comma, and then the corresponding new IDs I have down here. So if you're on channel 0, change it to 111 and hit enter. This code back here will begin the process for switching that particular circuit from UART to I2C and set its new channel ID to 111, respectively, for channel 0. When you're done setting the first channel to 111, simply type 1, hit enter to move on to the second channel, and then again type I2C, comma, 112. And you're going to want to do this for channel 0, 1, 2, and 3. Once you're done with that, we can move on to setting up the rest of the operating system. To finish setting up the DRO-Matic operating system, you're going to want to go back to the root of your extracted download, and in here you're going to have a DRO-Matic.ino. Now you can open up that with the Arduino IDE and upload the code with that. I happen to use Visual Studio that has a microcontroller plugin that allows me to do the same thing, just a little bit faster. So I'll do that now. You can see that it's compiling the code, and it will let you know once it's done. Alright, once done downloading, the first screen you'll see on the LCD of the DRO-Matic is SD card required, insert and reset. So if we haven't done so already, the SD card, this micro SD card, is going to need to be formatted with your Windows or corresponding operating system. And those are going to fit into the SD card adapter here, and then just slide that in here, and your operating system should recognize it. Once your operating system has identified the micro SD, you go ahead and right click on that and probably choose Format, and you're going to get a lovely format window. I usually just leave that as the default settings it chooses, but I make sure to choose Quick Format and then Start. It'll give you a warning about erasing all data. Click OK, and it should say Format Complete. Now we're going to take this micro SD out. And then plug the micro SD into the DRO-Matic. Once that's done, go ahead and just hit reset. And it will say crop setup, and it's going to ask you for a new crop name. Okay, so you're given an opportunity to name a crop. You're given 8 characters. The SD card does not allow you to have more than 8 characters. And the way that this works is you can scroll up and down through the alphabet and left and right through the different areas that you're allowed to move through. The whole operating system has what's called hotspots. So as you scroll this way, it's going to come back around to different hotspots and then back again. So basically, to move anywhere on the screen, you're going to be scrolling left to right, and to change a value, you're going to be going up and down. So we can call this crop, let's see here. Actually, we'll go back the other way around. We'll just call this A, B, C. Now you notice that as I went ahead and used the alphabet, it retained the last letter I used, because more times than not, the next letter you're going to use is closer to the previous letter that you used versus starting you back at the beginning of the alphabet. And that just makes it easier for naming crops. All right. Once you're done, you can just come back around, and while you're on done, hit select. And it's going to tell you that it's building the crop, and you get a little progress bar. And it's building out all the required files onto the SD in our new crop project that you just named. And there we go. Now you're presented with the home screen. So the home screen is fairly simple. You get the time of the day, whether or not it's AM or PM, the month, the day of the month, the current ppm level of your plants, and the pH level of your plants. All right, so the next obvious thing we should talk about off of the home screen is our LEDs. So the LEDs are basically just a large visual of the plant water pH level. And that's so you can see this from across the room, or just open up a garage and not have to come all the way over here and read it. Just make sure everything's okay. And the way that the colors work is basically off of your pH solutions. So when your pH level is too high, it's going to be giving you this color and telling you that the solution that it should be doing next is a pH down, aka red. When it gets too low, it's going to be doing a blue color, telling you that the next solution it should be using is a pH up. When you're in your pH range that you configure in the operating system, it's a green color. So you should be always coming out here and seeing a green color at all times, because the pH drifts are automatically taken care of by the DRO-Matic. All right, to interact with and ultimately configure the operating system, simply come up here and press either up or down and hold it for a few seconds until you get into the actual menu system. Now there's a series of first-hand menus, and we'll go over each one of these in a minute, but they are System Settings, Crop Settings, Pump Settings, Irrigation Settings, and Timer Settings. So to begin, go underneath Irrigation Settings, and we're going to go up to our flow meter calibration. Okay, it's this screen we're actually given the opportunity to calibrate our flow meters. If you remember, we have 2 flow meters for our irrigation system, one coming into the reservoir and one going out of the reservoir to our plant water. The one coming into our reservoir is a 3/4 inch, and the one going out from the reservoir to our plant water is a full inch. So obviously they're going to have different calibration sizes. The calibrations can be found with the specs that come with the actual flow meters, or you can find them online. They look something like this. So for our 1-inch flow meter, we have a frequency of F equals 4.8, yada yada yada. We're interested in that 4.8 number. And for a 3/4 flow meter, you're going to find the specs say something like frequency F equals 5.5. So let's see here. Our 1 inch is going to be our out, and our 3/4 is going to be our in. So 3/4 is going to be 5.5. So we'll move over to out. The out needs to be 4.8. And we can either go to back and hit select, and that will not commit your changes, or keep scrolling over and hit OK to commit your changes. Okay, it's now time to talk about reservoir volume. So we're going to go into irrigation settings, hit select, and then reservoir volume config. All right, and you're going to be presented with a screen that is zeroed out. And the way this works is, if you watch my other video on how to automate your reservoir, we're going to go ahead and put ourselves in a state where the reservoir is empty, but our water is off, and the valve is open. And we can go ahead and turn that water on now. And as the water comes through the valve and goes past our flow valve that we just calibrated, we should see these numbers start to climb. All right. Now, because this has been an automated setup, when the water level reaches a stopping point and that flow calibration is no longer reading the water coming through and these numbers have stopped climbing, you'll know exactly how big of a water volume you're going to have for your reservoir and throughout the crop. Now we're trying to target a volume that's going to be just enough to maintain all the plants and not go below our pump that's in our circulating control bucket here. So this is why we want to calibrate the reservoir volume now. Now let's talk about calibrating our EC probes. To do that, we're going to go into System Settings, EC Sensor Calibrate. Okay, dry calibration starting now. Remove probe some water. So I've done that, and the way that the EC calibration is that there's a 3-point calibration. So dry, a mid, and a high range. So we're at 0 right now. So we're doing our dry calibration. We can hit next. Low calibration starting now. Okay, so what I have right here is a 12,000 and an 80,000 solution, and I use this popsicle guy because it's a lot easier than using little cups. I filled up one chamber with water, and then the other 2 chambers with these different solutions. And the calibration that we just did is the dry calibration, which is out, and then we're going to dip it into our low calibration solution now. Okay, so with those sitting in there, you're going to read this number, and you're going to put that number in here. All right, so it was 0, 8, 8, 2, 1. Okay, so that's the numbers for our low calibration. Hit next. High calibration starting now. So this is where we're going to take the probes out and we're going to dip it in our just plain water, kind of wash them off a little bit, and move it to our high solution number. Okay. And we'll go ahead and read those numbers. And we'll just go ahead and put in 80,000. for this number. And just go down to done. And EC calibration finished. Now let's talk about our pH probe calibration. So we have a 3-point calibration again. It's going to be 4.0, 7.0, and 10.0. And using the same popsicle molder, I've gone ahead and filled up the first chamber with fresh water that we're going to use to clean the probes off as we dip into each solution. So going to the OS, we're going to go into System Settings, pH, Sensor Calibration, and it's going to say low calibration starting now. So what we're going to do is we're going to take these out and dry them off and then stick them into our low, which is the 4.0. I'm going to do a little jump cut here because I only got one hand. Okay, gone ahead and dried them off, moved them into the 4.0 solution, and on the low calibration, it's anticipating 4.0. So you might want to just let that sit for a little while, maybe 30 seconds, let the probes catch up, and then we can move over to next. Mid calibration starting now. So same deal, we're going to take these probes out, dry them off. Same deal, we're going to take these probes, put them in the water, swish them around a little bit, dry them off, and move over to our next solution. Okay, with those washed off and dried, we moved on to the next solution. It's anticipating 7.0. Again, let that sit for a little bit, maybe 30 seconds, and then hit next. And moving on to high calibration. So one more time, we're going to take the probes, swish them around in the water, dry them off, and move on to our last calibration solution. And finally, we're on to our 10.0 solution, anticipating 10.0, wait up to 30 seconds, and hit done. pH calibration now finished. So we can again swish these around. You don't need to dry them off at that point and just drop them back in to both reservoir and plant water.
Alright, so now let's talk about our regimen weeks and how to configure the amount of milliliters that each channel will dose throughout the regimen of our growth. So right here we have a general hydroponics sort of feeding chart, and you'll see they have the base nutrients right here, your Flora Grow, Flora Micro, and Flora Bloom, broken down into the amounts that you'll need for each and for what week it does. Seeding, early growth, transition, early bloom, late bloom, and then flush, right? You'll see that these charts are broken down by time, which is week 1, 2, 3, and 4, and 5, 6, and so on. Now, our operating system doesn't recognize weeks, but it recognizes regimens. And so the way that works is that if you were to follow this chart, after week 1 going into week 2, you could be potentially throwing out some fairly good nutrients, and all the way through the life cycle. As you transition from one week to another week, you could be throwing away really good nutrients, and that costs a lot of money. So instead of being time-based, our operating system is regimen-based. And so it's likely that when you set the amount of regimens, and it's recommended that you set the amount based off of weeks, that when you get done with your growth, you probably won't fall on 12 weeks. You'll probably fall somewhere outside of that or just below it, depending on how your grow goes and your plants took up those nutrients. But we're going to use this as our baseline to sort of set these little amounts with, and we'll do that now. Go into crop settings, and we'll go to number of regimen doses. And by default, the operating system set up 12 regimens for us. You can increase that up to 16 if you need, or down to 8. And when you're done, just go over to OK, and hit OK, and it will save it, and you're good to go. So now that we've set the amount of regimens, or weeks from our diagram here, on the operating system, we'll move into actually setting the amount. So for Flora Grow, We have 1 milliliter, 5 milliliter, 5 milliliter, and so on. And then it cuts off down here. And all these numbers for the next nutrient and the next. And down at the very bottom, it's going to say this is for 1 US gallon. So these numbers are for 1 US gallon. So if your reservoir is, like a 32 gallon, you're expected to take that 1 milliliter times 32. But you don't have to do that now. The operating system does that all for you because we get the opportunity to tell the operating system how big our reservoir water is. So all you need to worry about is focusing on just plugging in the exact numbers from your feeding chart here into the operating system. So going into channel settings, you get the opportunity to go through all of the different channels, and each channel is represented for each pump. So a pump is a channel. So we'll go into channel 1, and we're going to go to regimen milliliter configuration. So in here, it's going to tell you that you're currently on regimen number 1 and the amount of milliliters that you want to set on that. So we can go up, and based on our feeding chart, put in the right number for regimen week number 1. And then we'll just move over to next. And it says it's saving, please hold. And it opens up regimen week number 2, and you get the opportunity to set the milliliter for that. And so if you're utilizing the first 3 channels for your first 3 base nutrients, you'll just plug in all the numbers for those 3 channels, going down over your feeding weeks or regimens according to the operating system. And again, you don't have to convert your gallons. The operating system will do that for you. So this process should be fairly quick for you. All right. So now let's talk about ppm ranges, or EC ranges. So I know we went through calibrating both EC and pH, but now we need to actually focus on setting the ranges for those. And you'll notice here on our feeding chart, under each week, or regimen in our case, we have a number of 200 to 400 total ppm. And those numbers fluctuate through the different grow regimens. So going over to our operating system, we can go into crop settings and go into EC ppm range configuration. And it's here you can set the different ranges. So by default, it will put 500 and 700 always. And you get both the down and up, so it's actual range. And it will tell us on what regimen week we're on. So for regimen week number 1, we probably want 500 to 700 based on the chart. And then we move over and hit up. And next regimen, please hold. And it moves on to week number 2, where we can configure those. And moving on to next. And of course, when you're done, you can just scroll down to either back to go back to the previous set of menus, or hit done and save it.
To calibrate how many milliliters your pump motors can turn per minute, go into System Settings, Pump Calibrate. And here you get the opportunity to set the amount of milliliters per minute all of your pumps can do. Once done, hit OK. To prime a pump line, go into Pump Settings, the pump you wish to prime, and then Prime Pump Solution. Simply press up, and it'll begin priming the line.
So let's talk about top-off water and top-off concentrate. So as you give your reservoir a full dosing of the regimen formula you find on your nutrient bottles, you'll feed that entire reservoir worth of water
to your plants, and that's what your plants are going to feed on for about a week or more. And throughout that week, you may notice that different values would change. Now again, if you're doing this by hand, when these values change, you would have a second batch of water in a reservoir that is prepared, that is, like 1/3 the concentrate of the current amount of newts that your plants are feeding on, and you would start topping off your water with that top-off water. And when you're finished topping off a full reservoir worth of top-off water, it's time to flush your plant water and start a fresh batch of fully newted water. And so here, if we go from the home screen into irrigation settings, we can set the top-off concentrate, and we can make that 1/6, 2/6, 3/6. Usually they recommend 1/3 your concentrate of what your plants are feeding on for your total top-off volume. But we broke the fractions down a little bit further so you can get some really fine-tuning in there. If we go back, another thing in here, we can top off volume. So as the system begins to top off the plant water, you can tell it how much you want it to top off by. So it's sort of like microdosing your plant water with top off. Alright, so now let's talk about drain time. So if we go into irrigation settings, drain time configuration, it's here that you're going to be able to set the amount of minutes that you would like the system to leave open your drain line. And a draining happens when basically, as I noted before, in between full reservoir newts, you're going to have top-off reservoirs, and you're going to be topping off your plant water periodically, or the system will automatically be topping off your plant water. And when that full reservoir of top-off volume has gone away, or you've used it all, the system knows that that's a flag to drain your plant water. And it's here that you're going to set the amount of minutes that that drain is going to happen. So you can pretty much exceed that. So if it only takes 5 minutes to drain your plant water through your drain line, maybe you want to set that to 8 just to overdo it just a little. And then when you're done, just hit OK, and it will be saved. So now let's talk about setting the date and time that you see on the home screen here. The date and time is utilized for our power outlets here. And it's being ran with the real-time clock that we have going there. So you probably noticed throughout the video here that both the time and probably the days have gone all over the place. I haven't set it yet, so we'll go into System Settings and Date, Time, and Configuration. And it's here you get to set the hour, minute, whether it's AM or PM, the month and the day of the month, and the year. So just using the up and down arrows and scrolling around, you can set the minutes. The minutes, let's see here, if you go above 12, it goes back down to 1, but it treats it as PM, so you have to go all the way back around again. And then March, April will take you back down to the 1st if you switch the months out. And then you can change the day and then the year. And if you don't want to commit any of these changes, just go to back and hit select. Or if you do want to save the settings, scroll over to OK and hit select. Alright. Okay, let's talk about how to program our 4 power receptacles that can be timed down here. To start, I went ahead and numbered these 1, 2 for the front ones, 3 and 4 for the back ones. So coming up here to the LCD, we can touch up or down to get out of the home screen. And we're going to go to the timer settings. And in here you have a list of the 4 different receptacles
respectively. And if we go into one, you get taken to a menu which has an hour range. You can set AM and PM on those hour ranges. The day of the week, which is Monday, and the current week. So if we go over here and say we need, I don't know, 8 weeks or maybe even 16 weeks of light timing for receptacle number 4, we would just keep going up here and increasing this number by hitting up. It goes to number 2, 3, and so forth. And then coming over here, we can go from Monday, Tuesday, Wednesday, Thursday, and so on up to Sunday for that particular week. So you have an infinite amount of weeks, and you can get specific to the day of the week that you want to configure your hour range. There was just not enough space on this LCD to allow you to get down to the half an hour, but I figure, you know, hour range is fine. You're not going to need to go to that nth degree. Once you're done, you can just go ahead and hit OK, and that will save, and you're back to the timed receptacles. It's not until you actually hit start on the crop that the receptacles will actually start to work, but that is how you program one of the 4 different receptacles.
Alright guys, we are now at a point where we can begin filling up our bottles with our nutrients and amendments. And just remember that bottle 9 and 10 are reserved for pH up and down, and those are dedicated lines that go to our plant water bypassing our reservoir. Whereas bottle 8 is a dedicated pH bottle for a reservoir, and you'll need to determine if that's going to be up or down based on your water source, and that should be a constant. So that should be fine. Okay, so what's going to happen next is, being we still have the water filled up from our reservoir volume configuration, we can take the actual crop status off of pause and put it into a status of running by going into crop settings, crop status, and move over to paused and push up to running and hit OK. And what's going to happen now is it's going to begin to pH fix our reservoir water, nutrient dose it, and then eventually feed that to our plants. Begin filling up and then doing its top off dosing at the top off concentration that we've configured. And as the EC levels and pH levels drift over here from the plants, that will be auto corrected and top off water will be flushed to the plants. You hear it going now. So it's trying to pH correct. So there's a lot more OS configurations that you can get into, and all that's covered on the Wiki GitHub page. So I would suggest to go and check out the Wiki GitHub page if you haven't done so already. Don't forget that if you have a successful crop, to take the SD card out and upload that onto a possible future area. We can all share crops as a community. And I'm going to go ahead and be posting videos of this working with a running crop here shortly. But I just want to go ahead and thank everyone for watching. And I sure hope this has been informative. If you have any questions or comments, do so below. And as always, hit like and subscribe. Thanks, guys.